Hello students, welcome to Board Maths Made Easy. In this video, we are going to see the relationship between zeros of a polynomial. Relationship between zeros of a polynomial and coefficients of a polynomial. When zeros of a polynomial and coefficients of a polynomial. Generally, this particular relationship questions will come up to second degree polynomial. If you know it is because asking a third degree polynomial relationship is a bit complex to your level, but it is not like you don't know. Once you understand the concept, you can do it yourself. It is not a difficult thing, but because of the complexity to your grade, they highly limit always almost to only second degree polynomial. So if there is an equation called ax square plus bx plus c, it's not an equation, it's a polynomial. It is having roots alpha comma beta, then x minus alpha and x minus beta are the common factors of the given polynomial. Remember, they need not be if there is an equation, if it is multiplied by 2 or 3 or 4, the roots will not change. Similarly, in a polynomial, if you are multiplying the polynomial with the entire polynomial, even if you multiply with 2, 3, 4, 5, whatever be the number, the roots will not change. So are the roots really directly representing ax square plus bx plus c? If there is a common factor in a, b, c, if you take out that, then x minus alpha and x minus beta will be the common factors for the rest of the equation polynomial. So if a is having something, so instead of assuming x minus alpha, x minus beta are the only zeros, I would say a constant into x minus alpha, x minus beta, because x minus alpha, x minus beta will represent the non-common part. If there is a b, c have some common factor, that common factor will be represented by k. Okay. So if you multiply this and the this part, how would I say? If I say x minus alpha into x, that is x square minus alpha x, then I will multiply x minus alpha with minus beta x minus alpha into minus beta, that is plus alpha beta. So k into x square minus k into here minus alpha minus beta. So I took the minus outside and alpha plus beta into x, and then k into alpha beta plus k times alpha beta. So this is the same polynomial as x square plus bx plus c. So from these two, if we compare the exact coefficients, a is equal to k, b is equal to minus k times alpha plus beta, c is equal to k times alpha beta. If you recall, here alpha beta are the zeros of the polynomial, are roots of the given polynomial. But alpha plus beta, if alpha beta are the roots, alpha plus beta is the sum of their roots, right? Alpha plus beta is the sum of the roots or sum of the zeros, and alpha into beta are product of the zeros. So here alpha plus beta we need to find. If I have to find alpha plus beta, can I divide? I know this A, I know this B. I want to find the alpha beta. So I need to eliminate k. How I can eliminate? Alpha plus beta, okay, is equal to here minus b by k, and k is equal to what? A. Correct? From here we can say k is equal to a. So minus b by a. That way k is truncated. Correct? K is equal, here what I have done, alpha plus beta is equal to minus beta by k, minus b by k, and k is what? I have put a. So alpha plus beta value becomes the sum of the roots in a given polynomial will be minus b by a. So if any equation is given, okay, what is their sum? Minus b by a. Similarly, if I want to find alpha beta, so from here, what is alpha beta? Alpha beta is equal to, I know k alpha beta is equal to c. That implies alpha beta is c by k. C by k. But what I know, k is equal to a. So I will substitute instead for, because k is something we assumed. Alpha beta is given. Alpha beta are the roots, they said. And ax square plus bx plus c is the polynomial. So we need to find the relationship between the alpha beta and the coefficients. So k is introduced by us. Why? Because there may be some common factor. So that common factor we don't know, so we assumed it as a k, and in the final solution we should eliminate the k. So till this part are we clear? So what we know, alpha plus beta is called as sum of zeros. Sum of zeros are sum of roots. Sum of zeros are sum of roots is equal to minus b by a if the given polynomial equation is ax square plus bx plus c. Similarly, alpha beta is what? Product of the zeros or product of the root. Product of the zeros or product of the roots is equal to c by a. So if you know the roots, if you know the equation, can you find the sum of the zeros and can have product of the zeros? Suppose if there is a equation given x square minus 5x plus 6, a polynomial is given. Here what is the value of a? You always compare this with ax square plus bx plus c. So what is the value of a? A is equal to 1, b is equal to minus 5, c is equal to 6. Okay, we know that this has the equation has x minus 2 into x minus 3 as the factors, and 2 comma 3 are the roots or zeros. So if 2 comma 3 are the zeros, okay, if we follow this formula, do we get the sum of the zeros? Yes, let us see that. Sum of the zeros in the given format, in the given polynomial x square minus 5x plus 0 is plus 6 is equal to sum of zeros is equal to minus b by a. That is what here, b is equal to minus 5. Minus of b is minus 5 divided by a, what? A is equal to 1. So minus into minus 5, and product of zeros is what? Product of the zeros is c by a. We know it. Earlier we have found here product of the zeros is c by a. So c is what? 6. What is a? From the given example, x square minus 5x plus 6, 1. So product of the zeros is 6. So now we know the roots. Actual roots are 2 and 3. Their sum is 2 plus 3, that is 5. Is it matching to the sum of the zeros? Right. Similarly, product of the zeros, we know 2 and 3 are the factors. 2 into 3 is equal to 6. Is it matching to the product of the zeros? Yes. So if any polynomial is given, if they are asking you to find the sum of the zeros, you need to find the first, you give given polynomial, you match it to ax square plus bx plus c, write the value of a, write the value of b, write the value of c. Similarly, sum of zeros, you remember this important formula, sum of zeros is minus b by a and product of the zeros is c by a. If you remember these two, you can solve all related problems. The more number of problems we will solve in the exercise, but for now this is the concept. So the main and important point you need to remember is sum of the zeros is minus b by a, product of the zeros is c by a in a polynomial of type ax square plus bx plus c. Whatever be the polynomial given to you, you assume it as ax square plus bx plus c and write the value of a, b, c. And if they are asking you write the sum of the roots or sum of the zeros. Okay, both are one and same. Sum of the roots is commonly used whenever we are dealing with the equations, but otherwise it is sum of zeros. Okay, so similarly product of the zeros is c by a. Okay, so I hope you can do this. So let me take one example. Okay, one more concept. Suppose if they given you alpha plus beta, they said that they have not given you equation. They said the sum of the zeros of a given equation is given polynomial is something, some value. Similarly, they said the product of the given polynomial, product of the zeros of the given polynomial something. Now find the roots of the polynomial, or find the zeros of the polynomial. Here I am interchangeably using either zeros or roots, both are one and same, don't worry. So if alpha plus beta is given and alpha beta is given, can you find the alpha beta? The simplest logic we can use is, okay, if alpha plus beta whole square, we know it. What is that? Alpha square plus beta square plus 2 alpha beta. So here we don't know alpha square, we don't know the beta square, but we know alpha beta 2 times whatever the given value. Alpha beta, we know this. So alpha square plus beta square, you will get. See, most of the problems come in this kind of model only. They will ask you to find the alpha beta. So now we know alpha minus beta whole square. Even though we don't know, we know the actual expansion of a plus b whole square is square a minus b whole square, right? Similarly, if you write alpha minus beta from this particular part, alpha plus beta square whole square, what, let us say this they have given 7. So and this is given as 12. Okay, I am just giving example. Okay, alpha plus beta whole square is equal to 49, and alpha square plus beta square plus 2 times alpha plus beta is 2 times alpha beta is 24. So alpha square plus beta square is equal to what? 25. Now alpha minus beta whole square is equal to alpha a minus b whole square formula only. 2 minus 2 times alpha beta. So here alpha square plus beta square we already found, and 2 times alpha beta is 24 already. So alpha minus beta whole square is equal to 25 minus 24 is equal to 1. So alpha minus beta may be plus or minus 1. Correct? When you are alpha minus beta whole square is equal to 1, alpha minus 1 beta may be square root of 1. Correct? So square root of 1 is plus or minus 1, because when you doing square of a negative value, you will get a positive. So alpha, we know that alpha plus beta is equal to 7, alpha minus beta is equal to plus or minus 1. You take 1 first time. So when you take first time alpha minus beta is equal to 1, alpha plus beta is equal to 7, then if you sum 2 together, 2 alpha is equal to 8, alpha is equal to 4. If alpha is equal to 4, if you substitute here, beta you will get as 3. So this is one possible solution. And imagine alpha minus beta is equal to minus 1. What will be? 2 alpha is equal to 6, alpha is equal to 2 alpha is equal to 6, alpha is equal to 3. If alpha is equal to 3, beta will be 4. That means nothing but they are interchanging. Okay, the roots are changing. Like if one is 4, one is the other becomes 3. If the other is 3, the beta becomes 7, like that. So this is the way you can find the roots of the equation. So if this is the roots of the equation 3 and 4, what you can say, x minus 3 into x minus 4 is the polynomial. So if you expand it, x square minus 7x plus 12 is the polynomial. If you compare now to this, what they said, alpha plus beta is equal to 7. In our equation also, ax square plus bx plus c, if you rewrite that equation, x square minus b by a is this only, right? You have to alpha plus beta negative value minus 7 divided by 1. So you compare, okay, sum of zeros is minus b by a. So b is like minus b by a is equal to alpha plus beta. What is b? A times alpha plus beta into minus 1. Okay, so you need to understand that relationship. So does that clear? So we may see the other problems in the exercise 2.2 once you understand the concept thoroughly. So I am stopping this video here. We'll continue in the exercise 2.2 to do the similar problems. And remember, this is one of the easiest chapters unless you confuse your own thinking. Don't get confused. First thinking is ax square plus bx plus c is a polynomial. Then sum of the zeros is minus b by a. Product of the zeros is c by a. Okay, so the equation will become like x square, okay, plus b by a into x plus c by a. When you divide the entire equation by like this, I would say this one simply. See, if the given equation is a polynomial is in the format x square plus bx plus c, what I will do, I will divide the entire polynomial with a. Then ax square by a plus b x square x by a plus c x by c by a. So I know this is x square plus b by ax plus c by a. But if you remember, alpha plus beta is equal to minus b by a. So here if b by a is there, the negative of this value, make this coefficient 1 by dividing the entire polynomial with x square coefficient. Then whatever you get in front of the x, you treat that as a negative of this value, negative of this value, negative of minus b by a as sum of the zeros, as sum of zeros. Is that clear? Similarly, whatever here you are getting c by a, that is product of the zeros. If they give you for 1 mark, they will give you if sum of zeros of the given polynomial is this value and the product of the zeros is this, so write the polynomial. Remember, sum of zeros is minus b by a, but here you need to write b by a. That means you have to negate that. Negative of sum of zeros you have to write in front of the x. In place of the constant you have to write directly product. No need to do negation, right? So if they say sum of zeros of a given equation is 5 and their product is 6, sum of zeros is 5, product of zeros is 6, then write the polynomial x square. I said clearly, whenever you are writing sum of zeros, okay, you are dealing with minus b by a, but here in the equation you should write b by a. That means sum of zeros into minus 1 will give you the x coefficient. That means, okay, x square plus minus 1 into, okay, sum of zeros into x plus product of zeros as is, product of zeros as is. That's it. This entire polynomials, okay, revolve around this logic only. That means x square here minus 1 into x square plus minus 1 into what is sum of zeros given to me? Example, they gave 5 into x, don't forget this x, plus product of the zeros, they given as 6. There is nothing to write again. So x square minus 1 into 5. So x square minus 5 into x plus 6. So this is the same equation as whose roots are x is equal to x, whose roots are 2 and 3 are factors is equal to x minus 2 and x minus 3. So I hope this clears each and every doubt you have. So no need to think more than quadratic level. If you think cubical level, that will have a, you need to, instead of just assuming alpha beta, you need to assume alpha beta gamma, then x minus alpha into x minus beta into x minus gamma are the 3 factors. Then you do x cube minus alpha into the, you need to do all that expansion work. Okay, then you will see what is the x square coefficient, what is the x coefficient, what is the product of the coefficients. Okay, so this is the way you need to find the, then in this case what you will do, you will compare with ax cube plus bx square plus cx plus d. So a is equal to and divide the entire equation by a, because the highest degree of x, okay, for that the coefficient should be always 1. Suppose if there is an equation like say ax cube plus bx square plus cx plus d, and it has a power 3, the maximum number of zeros possible is 3. So I assumed alpha, beta, gamma are the roots. So alpha, beta, gamma makes, if you use in the factors, you will get the product. So if you do this expansion, you will get the sum x cube minus alpha into x, okay, I think you will get that minus alpha into x square minus beta into x square, all that expansion. So you need to do that product. Why we are not focusing on that is the scope of getting that level of question is not possible for your level. If at all you get it, you can do this way, similar to quadratic. I hope that is clear, and we will meet again in the exercise 2.2. Thank you.